Hello, 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 ladies and gentlemen. Root Beer here with question number 22 on the Cayley paper. In the diagram, A, B, C, D, E, F, G is a room having square corners. Okay. With EF equal 20, they have that labeled up here. AB 10, AG is equal to GF, even though it really doesn't look like it on their picture. The total area of the room is 280 meters squared. A wall is built from A to D, creating two rooms of equal area. So 280 divided by 2, 140. Interesting. What is the distance in meters from C to D? Okay, they gave us a picture. I'm going to draw the same picture so I can sort of scuff it up. So we have A, then we go around this way, B, C, some point here, D, E, F, G. And what did we have? AB is 10, EF is 20. And these are the same, and we've got this special length here, dividing the two rooms in half. And we're told we have square corners. So we'll put these right angles everywhere in here, and that might help us. When I put these right angles in, I'm thinking maybe we'll have to break the area down into things like rectangles, squares, and right angle triangles, all of which we are familiar with. And so then it'll probably just be sort of a chasing the diagram around sort of thing. Now, what did I want? I wanted CD, right? We'll just go back and check CD. That's what we wanted. What is the distance in meters from C to D? Okay, so I'm going to label that. This is my X, and I want to solve for X. All right. What can we do? Let's see here. I suppose. Well, let's start chopping the area up. So I know that these two areas, whatever they are, I'm going to call these two lengths, whatever they are, I'm going to call them Y. So let's use some colors to make it clear what we're doing here. So we're chopping this up. This is a square. This is Y squared over here. We've got Y. We've got Y. We've got 20 minus Y. And then this total distance here is 10 plus Y. So this guy, this ED, is 10 plus Y minus X. A little involved, but okay. If I chop him up, now I've got a rectangle of side lengths 20 minus Y and 10 plus Y minus X. And then what have I got here? I've got Y minus 10 plus Y minus X. So this should be, oh yeah, X minus 10. Yeah, that makes sense because we got 10 over here with AB. Alright, if I drop a perpendicular down here, I again have X minus 10, I have 10, and I have 20 minus Y. So now I know that all these areas should add up to 280. I know each individual side should add up to, each individual half should be 140. And that should give me a couple of equations. So I can likely solve for Y and X, although maybe I'll just be solving for X. Who knows? What have we got here? So we'll take a look at this half. And we'll have 140 is equal to, we've got 10 20 minus Y for this for this rectangle here, plus, and now we've got 1/2 base times height. Height is X minus 10. Okay, So because it's a right angle triangle, I know that we have base and height just from looking at the sides. So that gives me 200 minus 10y plus 1/2. Now we have to FOIL this out. 20x minus 200 minus xy plus 10y. And I can clean that up a little bit. I'll get 200 minus 10y, and then a half of 20 is 10x. Half of 200 is 100. We'll still have minus xy over 2, and then we'll have a half of 10, 5y. So 100 minus, 200 minus 100, 5y minus 10y, 10x, we'll have minus xy all over 2. Okay, so we've got the makings of something, I guess. Now if we look at, we'll put it in green, the green half over here, it should also be 1/2 of the total area. So we'll say 140. Actually, one thing we could do is equate these final equations. That might not be a bad idea. We'll get y squared plus now the rectangle. 20 minus y times 10 plus y minus x. And then plus half the triangle. So actually, these two halves cancel each other out. So maybe I should ignore everything I did up above. Should I? Well, yeah, let's see what happens. So this should be equal to 10 times 20. So it's equal to the other half. So we'll just plug the other half in here. It's equal to 10 times 20 minus y plus 1/2 20 minus y x minus 10. So I'm ignoring everything I did up here and here. I'll come back if I realize I've made a terrible mistake. But the point is, this and this cancel out. So now I know y squared plus, we'll deal with this guy in a moment, 10 plus y minus x is the same as 10 times 20 minus y. Now, the 20 minus y's catch my eye. I'm going to bring them over to the same side and factor them out. I'll have 10 minus 10 plus y minus x. So I can simplify that. So y squared is 20 minus y. We had 10 minus 10. Those will cancel out. And then, oh gosh, what was it? 10 minus 10, those will cancel out, and then we'll have minus y plus x. So x minus y. Okay, well, let's expand the left-hand side. 20x minus 20y, and then minus yx plus y squared. Well, the y squared is going to cancel out, and we'll be left with 0 is 20x minus 20y minus yx. That's a single equation and one unknown. I'm not liking that. What else can we do here? Well, we have 20x minus y is equal to xy. So I feel a bit stuck. We could solve for x in terms of y or something like that. Yeah, we could do that and then sub back into maybe one of these equations over here. probably the 140 is 100 minus 5, so I will actually have to use this. I shouldn't have so hastily scratched it out. That's something you might want to take forward. Maybe you don't do that. Maybe you're better than me. But I mean, I sort of scratched that out and said we're going to ignore it. I partly did it so that people watching this wouldn't be confused as to why I had just jumped down to another equation. But let's be honest, I did just actually scratch out some work. I want to bring that work back. Don't erase things unless you know they're not going to work. Don't scratch things out unless you know they're not going to work. So I'm actually going to bring them back. The 140 is equal to 100 minus 5y plus 10x minus xy, because I think that might be able to help me a bit. So I'm not going to rearrange anything right now. I also know 140 is 100 minus 5y plus 20x, or plus 10x, and then what was it, minus a half, minus xy over 2. Okay, so I can clean this up. We can have 40 is equal to 10x minus 5y minus xy over 2. Now, from this equation here, if I bring everything over to the other side, I know 20y minus 20x, so 20y minus x. Actually, we'll bring the xy over to this side. Xy is 20x minus y. So now if I substitute that in for this xy here, 40 is 10x minus 5y minus 20x minus y all over 2, but those will cancel out. We'll get 10x minus 5y minus 10x plus 10y. And then the 10x's cancel out. Very nice. 40 is 10y minus 5y, which is 5y. Y is going to be equal to 8. And as soon as I know that, I'm sure I could solve for my x's. 8x is just plugging it into this equation here. 8x is 20x minus 8. So 8x is 20x minus 160. So 160 is 20 minus 8, so 12x. Divide both sides by 4. We'll get 40 is 3x, or 40 over 3 is equal to x. I think that should be our final answer. Is that one of the possibilities? I know there were some over 3's. Yeah, there it is. 40 over 3, so that should be E. So I won't lie, that was a lot of equation hunting. I right now have the sense that maybe I went a little too fast. Not in terms of for actual viewership, but I have the sense that I went a little too fast, that maybe there's an arithmetic error in there. And sometimes you can get that happening when you just have equation after equation after equation. Oh, I can quickly plug this in. This. You can lose track of what's going on, and you can sort of get wrapped up in all the equations. Oh, I can rearrange this and this and this. And if you're quickly rearranging things because you've got a time crunch, you might sign just might not have flipped properly, and everything can unravel from there. So I have an x and a y. I suppose what I'd like to do is go back to one of those earlier equations, plug in, and see does this work. This is just going to be a little check, just because I feel I went through that quickly. I got 40 over 3. They only give you 5 answers. If you get one of those 5 answers, you do feel pretty good. But some of the ways that they make those other multiple choice, the other possible responses, is by, just goofing up. They do, when they're working out their solutions, they just run through it really quickly and don't think and see, oh, what did I get? And then, 50 over 3 might be the actual answer, but we goofed here. So what I'm going to do is I'm going to take one of my earlier equations, plug in my x and y, and see, does this really work? Okay? So that's what I'm going to do here. I'm going to take the y squared, so that's so 8 squared, that's 64, is 20 minus y, and then x minus y, so that's 20 minus 8, And we'll have 40 over 3 minus 8. So that'll be 64 is 12 times 40. 8 times 3 is 24. So part of that will cancel out. We'll get 4. And 40 minus 24 is 16. So this does seem to check out. If I wanted to, I could plug in even one of my earlier equations. So maybe 140 is 10 minus... I don't know, because those canceled out, not that they were necessarily equal. 140 is 100 minus 5y, so 100 minus 40, so 60, plus 10 times x minus 4x, so that'd be 6x, so that'd be 80. So 60 plus 80, yeah, that's 140. So we can just do these little checks to make sure, did we get the right answer? Did we go too fast? If you're confident in your work, by all means, you don't need to do that sort of stuff. But I like checking when I just get the sense. And if you've done a lot of these contests, you start to get the sense of, something's nagging at me, I did this too quickly. Okay, and that's a great time to stop, take a breath, move on to a different question, or check if you can. But, that's enough of question 22. Let's keep moving forward. Question 23 will be you for the next video, and I'll see you guys there.